All right, so this is composite figures, and we're going to start with equilateral triangles. The reason we're starting with equilateral triangles because an equilateral triangle a lot of times is part of a composite figure in the composite figures that we do. So if you look at this right here, this doesn't have any equilateral triangles on it, but I can easily add a roof to this house with an equilateral triangle. So I want to make sure that we see those, and as there's an equilateral triangle down here, and I want to touch on that. All right, so it says we've seen that the area of a triangle can be found by doing area equals 1/2 base times height, or base times height divided by 2. That's the same thing. In the case of an equilateral triangle, we know all the side lengths, so we can easily find the base, but what about the height? So let's find the area of this equilateral triangle, and then we'll practice with 2 more just to make sure we're okay. Okay? All right, so area of a triangle, 1/2 base times height. All right, remember, bases and heights are always perpendicular. So I see this horizontal piece right here. I'm going to highlight it. So this horizontal piece right here. So I'm going to use this as my base. If this is a horizontal piece, that means that I'm going to use a vertical line as my height. So to get that height, I'm going to draw in an altitude. So I'm going to go to this vertex right here, this vertex angle. And I'm going to drop an altitude, which creates a right angle, okay? And that's going to be my height, which is x, which is unknown. So now you look at, we just formed a right triangle. And you could look at it as the one on the left-hand side or the one on the right-hand side. It doesn't matter. Now I can find that height by using the Pythagorean theorem. And you might be saying, well, I don't know this. But remember, it's an equilateral triangle. So this is 40 centimeters. And then you might be saying, what about this? Well, when we dropped that altitude on an equilateral triangle, it's also a median. It cuts that side into 2 congruent pieces, which also makes it a perpendicular bisector. So this is 20 centimeters right here. So now what we can do is we can do Pythagorean theorem to figure out the height of that right triangle. So we're going to do x squared plus 20 squared is equal to 40 squared. X squared plus 400 is equal to 1600. X squared is equal to, if I subtract 400 from both sides, I get 1200, and then square root to solve. So the square root of 1200 is not a perfect square. We could always double check that by putting it into our calculator, but I'll show you. Excuse me. Let me move this over. All right, so square root of 1200, and we get a decimal. Okay, so I don't want to put a decimal down and then use that decimal to get another decimal answer. So instead, what we're going to do is we're going to put that the height is the square root of 1200. Okay, and then my base, I forgot to fill that in, but remember your base, I should have done that first, so I didn't accidentally put 20. My base is 40 centimeters. All right, now I can put this in my calculator. So I need to multiply these 3 numbers. I could either do this mentally and then do that number, which is 20 times root 1200, or I can type the whole thing in my calculator. So I'm just going to type the whole thing in my calculator and then show you also if I did mental math would be fine. So I could do, instead of 1/2, I'm going to do 0.5 times 40. Oops, I forgot the parentheses around my 40 times 40. And then times the square root of 1200. And I almost missed that 0 there. All right, so now I'm going to hit enter. And then it says round to the nearest hundredth. So we have the areas equal to 692.82. And then remember, this was centimeters and centimeters. Centimeters times centimeters is centimeters squared. So if I would have done the mental math and done this first, half of 40 is 20. And then if I would have done 20 times root 1200, I would get the same exact answer. Okay. All right, so let me move my area over here. Oh, I actually took my centimeters with me, put that back. Okay, let's try a couple more. Find the area of the equilateral triangle, round your answers to the nearest hundredth. So here's this next one right here. I'm going to do area is equal to Sorry, sometimes it gets stuck. Oh, I guess I'll just use, no, there we go. Area is equal to 1/2 base times height. All right, so this is an equilateral triangle. I'm going to use this horizontal piece as my base. I could use this and then draw my altitude here, but I don't really feel like it. So I'm going to say that's my base, 100. And then I need the height, so I'm going to draw in the height. Remember, this is a perpendicular bisector, so it's going to, because that's an equilateral triangle, so this is going to be 50 centimeters and 50 centimeters. This is unknown, which I'll call x, and then this is 100 centimeters. All right, so now we're going to do Pythagorean theorem again. So we're going to do x squared plus 50 squared is equal to 100 squared. X squared plus 2,500 is equal to 1,000, right? Or 10,000. Not bad. Subtract 2,500. I have x squared is equal to 7,500, and then square root. Once again, this is not going to give me a nice answer. It's going to give me a decimal answer. So I'm going to put the root 7,500 right here. And then 0.5 or half of 100 is 50. And then square root of 7,500. And I get 4,030.13 centimeters squared. All right, why don't you pause the video and try this last one on your own. All right, let's see how you did. Area equals 1/2 base times height. All right, so once again, I'm going to use this horizontal piece as my base. Since this is an equilateral triangle, I know my base is 57 centimeters, so that's my base. I'm going to draw in my height. Half of 57, so that's 25 plus 3.5 is 28.5 centimeters. All right. And then this is going to be my leg, my other leg of my right triangle. So we have x squared plus 28.5 squared is equal to 57 squared. All right, so I have x squared plus, I have no idea what 28.5 squared is, so I'm going to use my calculator for help on that. And that is 812.25. 57 squared is 3249. Subtract 812.25 from both sides. I'm going to move this up a little because I'm running out of room. There we go. All right, so now I have x squared is equal to, so I already have the 3249 on my screen. I'm going to subtract 812.25. I accidentally put 0.5 right there, but I remembered it said 0.25. 25, enter. So that's 2436.75 and then square root. So this is going to be, I didn't leave a lot of room for that radical. So I'm gonna do this. Square root of 2436.75. Okay. All right, now I'm gonna put this in my calculator. Half of 57 is 28.5, but I don't trust myself with that. So I'm going to do 0.5 times 57 times square root of 2436.75. All right, and we get 1406.86 centimeters squared. All right, so that's an equilateral triangle. So now we'll move on to actual composite figures that might have an equilateral triangle in it. Okay, So first off, what is a composite area? It says sometimes a large shape can be comprised of smaller pieces, or we have sections of areas we do not want to include. As a result, we end up breaking the figure into different parts and adding or subtracting the results. So here's an example. It says the wall shown below, that's that beigeish yellowy part, needs to be painted, but we will not be painting the door or the window. How much total area will we need to cover? So if you look at it, we have this giant rectangle, that yellow rectangle, but then we have to get rid of this door, which is another rectangle, and get rid of this window, which is another rectangle. So our plan is going to be to find the entire area, is we're going to find the area of the big rectangle, then we're going to subtract the door, that's a door, right? And then subtract the window, okay? Or we can subtract these two added together, which is the same thing. All right, so let's find the area of the entire wall. So it's a rectangle, and the formula for area of a rectangle is base times height. That's 8 times 16. So that area is 8 times 16, 128 feet squared. So I know it's less than that, right? All right, now let's find the area of the door. Base times height, because it's a rectangle again. 6.5 times 3. 6.5 times 3, 19.5. 19.5 feet squared. And then lastly, the area of that window, base times height. It's a 3x4, so the area of that is 12 feet squared. All right, so now we're going to stick to our plan here. We're going to do 128, the whole thing, minus the door, 19.5, minus the window, 12. So 128 minus 19.5. I hit plus. Clear. 128 minus 19.5 minus 12. And the overall square footage is 96.5 feet squared. All right, so let's get back to that fact that you have to paint that wall. So let's see how we could use this. It says we will need to apply 2 coats of paint. The chart below shows an estimate for roughly how much each quantity of paint can cover. So a quart will cover 100 square feet, and a gallon will cover 400 square feet. So how much should we buy? So if you're painting it twice, we have to do 96.5 times 2, which is under 200, right? And we would like to, I don't want to buy too much. I don't want to buy that gallon with 400 because then I have way too much, right? So I'm going to buy 2 quarts. Okay. All right, so here's some mixed practice. These are some composite figures that you would possibly have to find the area of. So let's go ahead and try these. If you'd like to pause the video and then just compare answers, you can. But a lot of these composite figures can be broken up into shapes that not necessarily you broke them into. Like we might have different things with the same answer. I say the least amount, the better. So if I look at this figure right here, what I'm seeing right now is that I can break this into a rectangle and a trapezoid. Now I can draw a line this way and create a rectangle and a trapezoid. Or I can draw a line this way and make a trapezoid and a rectangle. So it doesn't matter which one you do, as long as you find the area of both, you should be fine. So I'm going to try it this way because I just can leave it there. So I'm going to do area of the rectangle. So my plan is to do the rectangle plus the trapezoid. Okay, so I'm going to start with the area of the rectangle, which is base times height. All right, so I'm looking for perpendicular pieces. This is 22 and this is 10. So 22 times 10, and the area of that rectangle is 220 centimeters squared. Now I need the area of the trapezoid, which formula for area of a trapezoid is 1/2 the the two bases added up times the height. Now, if I'm missing any of this information and I can't find it, then I'll switch to drawing the line this way. Or if you look, I can break rectangle, rectangle, trapezoid, but that's more work, so I don't want to do that. Okay. All right, so for this trapezoid here, I need my two parallel bases. So that's this and this. And if you look, this itself right here is not labeled, so I got to figure it out. The number one thing people do wrong is that they just chop that number in half. They're like 12, okay? That's not how you do this. We know that this piece is 10 centimeters because it's the same length as this. 24 minus 10 is 14 centimeters. So that base is 14 centimeters. This base is 8. So my bases are 8 and 14. And then my height is this perpendicular piece to my two bases. We're going to figure it out similarly. This whole thing is 22. We're not taking half of that. We know that this part is 12. 22 minus 12 is 10 centimeters. So this is 10 centimeters, so the height of that's 10. Okay? All right, so I have 0.5 times 8 plus 14 times 10. And I get 110 centimeters squared. So now just stick to your plan, add those two numbers together, and I get 330 centimeters squared. All right, let's try another one. This one says a cement walkway is installed surrounding a swimming pool. How many square feet will be needed? So the way I look at this is that I'm going to find the area of the whole entire thing because that's one giant rectangle, but then I need to get rid of this pool right here. All right, that'll give me the walkway. All right, so I'm going to do big rectangle minus small rectangle. So that's my plan. Area equals big minus small. Okay, so I'll start with the area of the big rectangle. Base times height. Perpendicular pieces, these two are perpendicular. That's 32 and 26. 32 times 26 is 832 feet squared. Area of the pool, all right, the small rectangle. It's a 24 by 18. 24 times 18 is 432. Now I just need to subtract those. 832 minus 432 is 400 feet squared. All right, here's our next one. To make a stop sign, a worker starts with a square piece of sheet metal and then cuts off the corners as shown below. How many square inches of metal does the resulting sign have? So it started off as this, and then I got rid of this, this, and this, and this. So my plan is going to be take the square, because that's what it said it was. So plan is area equals the square. And then I'm going to subtract, instead of doing 4 triangles, I'm going to do 2 squares, because I'm going to say this together makes a square, and then these two together make a square. So I'm going to say minus 2 small squares. Okay, you could do minus 4 triangles. It's the same thing. All right, so let's start with our plan here. The area of the big square. You either do side squared or base times height since the square is a rectangle. 30 times 30, 900 inches squared. And then I'm going to do the area of the small square. This is an 8.8 by 8.8 square if you put this one and this one together. So 8.8 times 8.8. 8.8 times 8.8, 77.44. And then remember there's 2 of those. So there's a square here, and then there's a square here. Okay, so in my calculator, I'm going to do 900 minus 2 times 77.44. So 900 minus 2 times 77.44. And I get 745.12. 745.12 inches squared. All right. The last problem here, it says this figure is an equilateral triangle with a trapezoid on top. And if you look, it's an isosceles trapezoid because I can see that these two pieces are congruent. Find the area of the figure. So my plan is going to be to find the area of the whole thing is I'm going to take the area of the trapezoid plus the triangle. All right, so I'll start with the area of the trapezoid. Area equals 1/2 base 1 plus base 2 times the height. All right, so my bases are my parallel pieces. This one's 20. And this, at first I might say like, oh, I don't know it, but you do. That's an equilateral triangle. So this is 40 centimeters. So my two bases are 20 and 40. And then I need the height, which the height is not drawn in. So I can figure out what this height is. This is X. And then I have to figure out what this piece is right here. Now, if I draw in, that doesn't look accurate, but if I draw in the other height right here, okay, I know that this piece must be equal to this piece. So if I do 40 minus 20, which is 20, and then divide it by 2, I get this is 10 centimeters and 10 centimeters. That's 10, 10, and 20 centimeters. All right? Okay, so now I can do Pythagorean theorem to figure out that side. So I have x squared plus 10 squared equals 20 squared. X squared plus 100 equals 400. Subtract 100 from both sides. I have x squared equals 300. And then square root, and I get the square root of 300, which is not a nice answer, so I'm just going to leave it for now. All right, then I just need the area of the isosceles triangle. That's area equals 1/2 base times height. All right, so I'm going to use this as the base, which we already said is 40. Then I'm going to draw in the altitude. I'll call that A. I don't want to call it X because I already used X for something. I know this piece right here, from here to here, is half of 40, which is 20. So I'm going to do A squared plus 20 squared is equal to 40 squared. A squared plus 400 is equal to 1600. This seems really familiar. A squared is equal to 1200 square root. Yeah, we already did this equilateral triangle. All right, so the base was this whole entire thing, which was 40, and the height was root 1200. All right, so now I want to get the area of the figure. I'm going to add these two things together. So I'm going to do 0.5, parentheses, 20 plus 40, which is 60. So I'm going to add that in my head. You could type 20 plus 40, though. Square root of 300. This is all multiplication right there. Okay, and to that I'm going to add 1/2 times 40, which I could have just done 20, but it's too late now, times 1200. I'm really hoping it did order of operations here, but we'll find out, or will be. I'll double check my answer. How's that sound? And delete that, come back under there, 1200. All right, let's see what it's saying. 1212.44. So I'm going to double check that because I don't know if I typed it in the calculator correctly. So let's try it one more time just to make sure. So I'm going to do 1/2. 20 plus 40 is 60. And then the square root of 300. So that is 519.62. And then 1/2 of 40 times square root of 1200. And that is 692 plus 0.82. So if I add that, this plus this, I get the 1212.44. Okay, and there's your answer. All right, that's it for today's notes. Go ahead and try your homework.